So it says I could do like 1 over the differentiation to do arc sin x.
Mm-hmm.
Does that
X.
mean, do I need to flip over the fraction then, or?
The derivative of this one. Let's say x involves a square root. Is it to do with? Okay. Let's see. So y is equal to arc sine x. And so maybe do sine to both sides.
Yeah.
What would you get?
Sine y equals to x.
Yeah. And then I believe it would be dx dy. So like differentiate both sides.
Do I need to differentiate sine y?
Yeah.
And that'll be cos y.
Yeah. So that's dx dy.
Uh, and then do I need to do 1 over cos y?
And then dy dx is 1 over cos y. What is y?
Arc sin x.
So is that 1 over cos arc sine x? That feels wrong. That step, is there some trick? There's probably some trick, like we need to square both sides. Yeah, let's say at the cos y part, we could do cos squared y equals this squared. Or maybe having it as dy dx doesn't hurt. Okay. How can we change this into sine?
Do 1 minus sine squared y.
1 minus sine squared y. Yep. Let's see. Then we could square root both sides. So square root of 1 minus sine squared y. Then flip and then replace with what sine x is equal to. Or sine y is equal to.
So it'll be 1 minus x squared equals dy dx.
That's it. Phew. Let's see. So how does this work? So let y be equal to arc sine x. Sine both sides. Differentiate both sides. And then square both sides. So you don't have cos of arc sine. So you have so you can swap. So you have to square cos to swap it into 1 minus sine squared, and then you go from there. And yeah, this will happen a lot, where you take the x equals from earlier and sub it in. All right. Any questions so far?
No.
Oy. All right. How about this?
So would it be like 1 over a root 1 minus x to the 4, or
You jumped in a lot. Sine both sides.
so if I sine both, so that'll be sine y equals to x squared,
Mm-hmm.
and then dx over dy is equals to cos y.
Hang on, this is x squared.
Yeah.
Let's see. Let's try squaring both sides at this point so you get the x to the 4.
And so that'll give me sine squared y.
Squared y. No, that might be more work. Let's do it your way. We could square root both sides. Alright, square root both sides. What do you get?
Square root of sine y equals to x.
Y equals x. And then
Do I then need to
differentiate both sides?
so square root of sine y, so is that going to be the same as like sine y to the half to a half?
Yeah.
And so will that be like half cos y?
Let's see, that's to the half. That would be a half sine. And so another way to write that would be
It'll be a half sine y and then cos y.
and what would be the new power?
Minus half.
Yeah. Minus half cos y. That's equal to dx dy. What does next?
I need to do 1 over that.
Yep. So dy dx is 1 over that. This is in terms of y. We want it to be in terms of x.
Do I need to sub in do I need to solve for y and x so that, like, do I need to do like arc sine of x squared equals to y?
Yeah. Well, what is hang on, 1 over that one. So I'm just kind of simplifying as I go. Not sure if I should. A half, if you do 1 over half, you get 2. If you do 1 over to a negative fraction, you can bring it up, making it a positive. And so that's the only one on the bottom. What is sine y the same as?
Like in terms of cos or
No, in terms of x?
squared.
Yeah. 2x squared to the half. What does that simplify to?
So will that be like 2x over cos y?
Yep. And so now we'll get cos y in terms of sine y, so we can change it in, we can swap it with x.
Sorry, what? What did I do? Sorry.
So you know the way we just swapped sine y with x squared?
Yeah.
So write cos y in terms of sine, so that we can do the same thing.
Oh, so will that be like 1 minus, no, square root of 1 minus sine squared y, or
Squared y, yeah, you're right, it is 1 square root. Yeah.
and will that then be like 1 minus x to the 4?
Yeah, x squared squared. So there we go. And so dy dx is 2x over square root of 1 minus x to the 4. Let me see. So let's say, okay. So y equals arc sine x squared. We sine both sides. Then we square root both sides so that we can have x equals. so that we can get dx dy. We get dx dy, then we flip it. The problem is we have dy dx in terms of y. We want dy dx in terms of x. So wherever you have a sine y, replace it with x squared. And then wherever you have cos y, convert it in terms of sine so that we can replace it with x squared. Let's see, 2x over root 1 minus 4x to the 4. There we go. All right. Any questions about this?
No.
So they did it doing this thing. What was it? Let t be equal to x squared. Let y be equal to arc sine t. Yeah, you could do it that way, I suppose. Parametrically. Okay, how about this one? Hang on, before we do crazy stuff. Looks like it might just be crazy. Not really. Hang on. These questions. Let's see. X equals. Okay. Oh, a little bit weird. Okay, let's try this one. Oops. Hang on, I'll just bring this thing just in case. Let's see.
So, am I doing? Do I need to do 1 minus x times 1 plus x minus 1?
To the what, sorry?
To the minus 1?
Why would you do that?
I don't know.
I think tan both sides.
Of course. So it will just be tan y equals to 1 minus x over 1 plus x.
Yeah. So I was thinking we would get something like x equals, and then we would differentiate both sides and get dx dy equals. I think that's what we have to aim for. But how can we get just 1x by itself or something?
I'm not sure.
I believe you have to multiply both sides by denominator and then eventually fully expand, fully simplify, collect the x terms and factorize them.
So multiply, and then, so I've now got 1 plus x tan y equals to 1 minus x.
Hang on. Yep. Sorry, go on.
I don't know, should I separate it and do like tan y plus x tan y equals 1 minus x?
Yep. And then
am I trying to solve for x here? Or?
yeah. make x the subject.
So I'm assuming, do I do like x plus x tan y is equals to 1 minus tan y?
Mm-hmm.
And then I do factorize out x, and then do 1 plus tan y equals to 1 minus tan y, and then just do x is equals to 1 minus tan y over 1 plus tan y.
Mm-hmm.
And then do I do I now need to differentiate it?
Mm-hmm. How do we differentiate it?
I'm differentiating tan y, aren't I? The tan y's.
Yeah, we have to differentiate the whole thing though. So how do you differentiate this fraction?
So I don't do like 1 minus tan y times 1 plus tan y or something.
You could convert it that way. You could do quotient rule because it's one divided by another. Or you could change it to the minus one thing you're talking about and do product rule. It's all the same.
I forgot what the quotient rule was. Was that like dx over du times du over dy or something? Or
If I remember correctly, it was v u dash minus u v dash all over v squared. Let me just check quickly. Yeah. So let's say u equals v equals.
so am I doing v u dash minus uv? So will that be like so 1 plus tan y times by what was the differentiation of tan y? Sorry.
I should be here, is it? No, it's not. I believe it is sec squared y. F of tan x. Sec 2x. Oh, are they saying sec squared x? But they're just formatting it like that? Yeah. Sec squared x.
Is it sec squared x? Sorry.
Yeah.
Okay. So will it be just minus sec squared y?
Yeah, I'll do it at the front because it's times. So
Yeah.
like negative sec squared y. Yep.
And then minus uh minus sec squared y times by 1 minus tan y
Minus tan y. Yep.
over 1 plus tan y squared.
1 plus tan y squared. What is next?
Now this is where I probably need to like simplify it.
Okay. Let's hold on. So this is dx dy. We want dy dx.
Oh, so I need to do 1 over that.
Yeah. And so
I just fraction.
yeah, we just flip the fraction. And so that is dy dx. And if we go all the way back, we said tan y is 1 minus x over 1 plus x. Does that help? What can we write instead of tan y?
Was there something like that we'd written that was equals to tan y initially?
Yep.
So we wrote that tan y is basically equals to
very first thing we wrote.
Tan y equals to 1 minus x over 1 plus x. Yeah.
Yeah. And so we're trying to write dy dx not in terms of y, but in terms of x. So what would we do there?
Sub in all the 1 minus x and 1 plus over 1 plus x for all tan y's.
Yeah. And so everywhere you have a tan y, replace it with 1 minus x over 1 plus x. However, we have more than just tan y. What else do we have in terms of y?
In terms of tan y?
In terms of y? So we can get rid of the tan y.
Yeah. Oh, we have sec squared y as well.
So what do we do about that?
So sec squared y is actually the same as 1 over cos squared y.
Yeah.
Which is the same as 1 over 1 over. I think it's going to take like some sort of long trigonometry the way I'm trying to do it, and it might not be right.
Let me just check something quickly. Sine squared x plus cos squared x is identical to 1.
Yeah.
We want 1 over cos. So we divide everything by cos. And so that gives us 1 over cos over here. What is that equal to?
That's equals to 1. Oh no, sorry. Tan squared x plus 1 equals to sec squared x.
And tan squared x, if I did y, what did we say tan y was the same as?
Like 1 plus x over 1 minus x.
Yeah.
I
think it was 1. Yeah, 1 minus x over 1 plus x.
Yeah.
And so what can we do? What is sec squared y the same as in terms of x?
1 minus x over 1 plus x squared plus 1.
Yeah, 1 plus x. So that's using the trig identity that connects sec squared x and tan squared x. So we have to replace it with 1. So that was on the top. This one, 1 minus x over 1 plus x squared plus 1. And then this one was the same thing. 1 minus x, 1 plus x plus 1. So wherever there is a x squared y, we replace it with 1 minus x over 1 plus x squared plus 1. Wherever there's a tan y, we replace it with 1 minus x over 1 plus x. And I'm sure that that can be heavily simplified, but I won't, because if you need to find the gradient, you just sub it in for x. But if needs be, wow, it really does simplify down. Minus 1 over 1 plus x squared. There you go. So let's see. Arctan u. Cool. They did the same thing. U is this thing here, and then you sub it back in. Right. Seems like it comes up a lot where you have to like sine or cos or tan both sides, and then you have like that, you know, sine y, cos y, tan y in terms of x, and then you later on sub that in, so you swap from dy dx to in terms of y to in terms of x. All right, any questions with that?
No.
So we did arc sine, arc cos, arc tan. I just want to see, am I crazy, or is this just doesn't look very similar? So the exam questions look similar to each other, but they don't look similar to... Did I put this in the wrong... This looks like it. Oh gosh. Okay. This is what the exam questions look like. How about this?
Okay. So, let's see, as equation 1 is not 20, not 21. Value of t minus x equals to 2 is... Are they just asking me to sub in root 3 over 2? Oh no, they're asking...
Into dy dx.
Yeah, they want me to differentiate it first, and then after sub in root 3 over 2.
Yeah.
So, okay. Do I need to do xy equals to arctan 2x?
I don't think so.
Okay.
I think you could just, because it's y equals.
Yeah.
Maybe. I think you might just do dy dx.
Am I allowed to just use my calculator for this answer? Oh no, I can't, because they've already given me the answer.
Yeah, it says show that. Let me just formula booklet for a second.
Yeah.
Just want to see if they give arctan for the derivative, and if they do, then that skips a lot.
Yeah.
That's AS. So the derivative, no, they don't. And then the integral arctan. All right. But we have to show that before we go crazy. So they just went straight to quotient rule. They just went straight for quotient rule. 1 second. So what did we say the derivative of arctan x was? We didn't actually. We never simplified it. Oh no. The derivative of arctan u was 1 over 1 plus u squared. So that is the derivative of arctan. One over 1 plus x squared. And so we could do quotient rule.
Okay, so is that where it's like vu dash minus uv dash over v squared? Or...
Yeah.
Okay, and now I need to do. So was that so? And that arctan 2x over x is the same as u over v, yeah. And so do I now do so x times arcs x squared 2x?
It doesn't work that way. The derivative of arctan x is 1 over 1 plus x squared. Any idea what will be the derivative of arctan 2x?
Two y. Not sure.
I believe. So if the derivative of arctan x is 1 over 1 plus x squared, so that's the simplified version of what we did.
It'll be 2 over 1 plus x squared. Or when
I think it'd be 2 over 1 plus 2x squared in a bracket.
Okay.
So what is 2x times 2x?
4x squared.
I hope that's it. Okay, go on.
Do I now need to time? Oh, and now I do plus. Oh no, minus. Sorry, minus arctan 2x time just arctan 2x on its own, I think.
Yeah, times 1.
All over x squared.
For x squared. Okay, what is next?
Do I now need to sub in root 3 over 2 into the x values?
Yeah, and
then I have to just do equals to 3 root 3 minus 4 pi over 9.
Yeah, that's good enough for me. Root 3 over 2 squared. Okay, how would you do part B?
Find the equation of normal to the curve at x equals root 3 over 2. Are they asking me to do, is that like for a straight line equation? I think.
Yeah.
Oh, so I've basically got the gradient now, I think.
Yeah.
To get the gradient, so the gradient is 3 root 3 minus 4 pi over 9.
Yeah.
Okay, I know what I need to do. It might be a bit long, but I think I need to do sub in root 3 over 2 into the y equals.
Yeah, so that'll get you the y coordinate.
Then sub in root 3 over 2 into the x coordinate. Then sub in root 3 minus 4 pi over 9 into the m. And then just do plus c and solve for c.
Yes. What is the m, sorry?
3 root 3 minus 4 pi over 9.
That would be for equation for a tangent. This is normal. So
I need to do, because it's normal, does that mean I have to do minus 1 over m of the grade? Yeah.
So
will that just be like minus? Do I just need to do minus 1/3 √3 minus 4 pi/9?
How do you do that? 1 over a fraction.
Do I flip it?
Yeah.
And so do I get -9/3 √3 minus 4 pi?
Yep. Minus. You can put the minus lots of different places, but that would be it. And then you would solve for C. So that second part is, I think that's going to be all right. That's standard. You know, there's a reason why you differentiate it. It's so that you can do that stuff. Let me just see A. Yeah. 2 over 1 plus 4x squared.
Yeah.
Got it. Great. Any questions there?
No.
Okay, so we kind of proved this a minute ago, that the derivative of arc tan x, fully simplified, is 1 over 1 plus x squared. Yeah, it really helps fully simplify it. And so the derivative of arc tan 2x is 2 over 1 plus 4x squared. And then we can just use that. Oh, yeah. Okay. So these are what the exam questions look like for these ones. Right, how about this one? This time it's cos.
You see, curve says equation x equals r cos 1 squared. Show that 1 minus cos squared. Okay.
Hang on, so we previously found arc cos y. It wasn't arc cos wasn't too bad. Oh, did we? That was arc sine. That was arc sine, and that was arc tan. We didn't actually find arc cos. Let's do it now, before we start monkeying around with this thing. So let's say y equals arc cos x. So let's find dy dx for this one.
Okay, so dy dx for this. So
we don't know what the derivative of arc cos x is.
Is that where I cos both sides?
Yeah.
So cos y equals to x.
Yeah.
And then do I square both sides?
No. I think differentiate both sides.
So I'll do dx over dy.
Yeah.
And then I think that gives me like minus sine y.
Yeah.
So if that's, do I then do 1 over minus sine y for dy over dx?
Yeah.
I then need to now do arc. Do I need to sub in arc cos of x for y and get 1 over minus sine arc cos x?
Use this one.
Okay. So that's cos y. Do I need to now change that into sine y?
Yeah, or you could change this one into cos, however you do it.
So if I change minus sine y into cos y, that'd be like 1 minus sine cos squared y. Or
Yeah. Let's say, and don't forget square root.
yeah, sorry, square root of 1 minus cos squared y.
Let's see. Just not sure. Sine squared y is 1 minus cos squared y, and so minus sine squared y would be minus 1 plus cos squared y. How do we get just sine y? if it's negative, we could just put the negative on the outside. Just putting the negative on the outside. 1 minus cos squared y. Okay. And then
sub in, then just do minus bracket 1 minus x squared.
let's see. Yes. So dy dx is 1 over, and expand the negative bracket. What would you get?
Minus 1 plus x squared.
Yeah, and I'll write it as x squared minus 1.
Yeah.
So dy dx of arc cos x is 1 over x squared minus 1. Okay. Let's go back. Okay, let's try this one.
So that dy. So do I need to square that differentiation?
So start with the thing up here.
Yeah.
Do you mean square root both sides?
Yeah, sorry.
Try just going straight for it. Try just differentiate both sides.
So do I need to do 2 times cos y?
Well, 2 arc cos y.
Oh, and then just do 1 over x squared minus 1 at the end.
Yeah. 1 over x squared minus 1.
And then I can just check 2 over x squared minus 1 over times arc cos y.
Yeah. And actually, maybe we should have done. So, so that's, what is that equal to?
The root 1 minus cos squared root x over 2 root x.
Hold on. Dx dy?
Yeah. Oh, so dy dx is that fraction flipped over.
Yep. We have it in terms of y, so we have to make it in terms of x. Well, x and y we have. So maybe yeah. Now we do the square root both sides thing. We did need to do it.
Okay. So I'm guessing I need to simplify this further then.
So go back up to the start and do the thing that you were saying, where you make y the subject.
So that would be square. So square root of x is equals to arc cos of y.
Yeah. Oh, hang on. That might be enough. Square root of x.
And then I can just do 2 square root x at the bottom as the denominator. Sorry.
Yeah, x squared minus 1 over 2 root x. Theirs is we have 2 root x on the bottom. Ours is simpler than theirs. 1 minus, I think because we did this here. Let me just check this. So y equals arc cos x. Cos y is equal to x. Dx by dy is minus sine y. Dy dx is 1 over. Dy dx is, yeah, so this thing here, where we would have gotten cos squared y minus 1, they left it as cos squared y minus 1, and they have the minus on the outside, so it's minus 1 minus cos squared y, and y is root x. Is that right? Let me see. Root x cos root x is y. Ah, yeah, cos root x is y. If we had done this one here, we would have said y equals cos root x. Our one is much simpler though. Okay. Ours is much better than their one. Let me just see something here. Yeah. Okay, Grant. Any questions there?
No.
Yeah, our one is better. Let's see this. So then there's lots of reciprocal trig. So they lump them all in. I could do one. Let me see. Yeah, just lump them all in. Okay, but big picture for these ones is like what we did with the sine. So you do like sine or cos or tan of both sides. Then you have like x equals something in terms of y, which you might later need to replace the y. Always go upwards if you're replacing sine with cos, that type of stuff. Go up to squared, so you keep the positive and negative answers. If you do like sine of arc cos, then you lose the negatives. Differentiate to get dx dy, flip to get dy dx, and then swap all the y terms with x terms. So you have dy dx in terms of x. Let me do one thing. 1 sec. Copy this from the formula booklet. They just go straight into this thing. Okay, what is dy dx? So this is kind of quite different. This is reciprocal trig using the formulae.
So reciprocal trig. Was there something that cos x sin x was the same as or something?
1 over cos x is the same as something.
Sec x. No.
Yeah, and the other one?
Cosec x.
Yeah, and in the formula booklet we have formulae for those. So that's y. So find dy dx.
Would it be minus cosec x cot x and times sec x tan x?
Let's see. So this, I believe, would be equal to uv.
Yeah.
Because it's an x function times another. So this would be product rule.
Yes.
Let's see. So it's a lot like the other one. vu dash uv dash, but you've got plus in between and no denominator.
So do I now need to do so cosec x times by minus 1 over sin x?
What's the derivative of sec x?
I assumed it'd be 1 over minus sin x.
Formula booklet.
Right. And so that would be sec x tan x.
Yeah.
And then minus.
Plus.
Oh, sorry. Plus. So we just did u v dash. I have to do v. So I need to do now sec x. I think.
Yeah.
Times by minus cosec x times cot x.
X cot x. Yeah, that's it. Let's see, cosec x. You could factor and stuff, but don't know. Is it even necessary? Let's factorize. cosec x sec x, and you get tan x minus cot x. So that's, we have the fewest number of x's. How about question B?
Number of stationary points of the curve C. Is that where I do like the differentiation equals to 0?
Yep. So that will be equal to 0.
Can I put it into like my graphical calculator or something?
Let's say B equals 0. Suppose you could, let me see, determine the number of, I think what you could write it as is, so this, we factorize that and it's equal to 0.
Yeah.
And so I suppose you could write it as cosec x sec x equals 0, or tan x minus cot x equals 0, and put them in separately and do it that way. And how about question C?
Yeah, I think it's just what I need to do here. So if x is pi over 3, that means that for to get the y coordinate, I sub in pi over 3 into 1 over cos x sine x.
Yeah.
I then sub in pi over 3 for the x coordinate. Then m sub in pi over 3 into the differentiation we found, and I just do plus c.
Yep. And then solve for C and go about it that way.
Yeah.
Let's take a look. So dy dx equals 0. Oh wow. Using the product rule, yeah. They did some wacky stuff and simplified it down. Oh, so all they did was change it back. So cosec x sec x, they changed that into the original one, 1 over cos x sine x. Aha. At the stationary point, they just solved it. Okay. And then C, they did the same thing. All right, fair enough. Any questions there?
No.
Let's see. Show that. I just want to see this one. If y equals cosec x, so you'd have to prove it. Cosec x cot x. I think I know. Do 1 over. And then, all right. Let's see. Show that. Maybe. They really, oh, that's, okay. They really threw them all in at the end there. Just want to see sec for x. Let's see if we can quickly do this one.
So dx dy in terms of y. Is that just going to be? So I've got cosec there. Will it be minus?
This is sec for what?
Oh, sorry. So that will be just for sec 4y tan 4y.
Yeah. Oops. And then B.
Just do 1 over all that. Oh, and then I need to like find something for x, don't I?
Yeah. So what is x equal to?
Sec 4y, so it'll just be. So for now, I know it's going to be 1 over 4x tan 4y.
So we need to convert between sec and tan. Do you remember identity for that?
No.
So we did this earlier with this thing. Oh no, we didn't actually. So we need tan. So divide everything by cos. What do you get?
You will get tan squared x plus 1 equals to sec squared x.
Yeah. And so what is sec squared 4y the same as?
X squared.
So, okay. What is x squared the same as in terms of tan?
It is going to be tan squared x plus 1, x squared plus 1.
Okay. So
Yeah.
tan squared, all right, 4y plus 1. And so we need to make it tan 4y equals.
And so that will just be square root of x squared minus 1.
X squared minus 1. Yeah. And so this thing in terms of x
will be 1 over 4x square root x squared minus 1.
square root x squared minus 1. 1 over 4x root x squared minus 1. Great. And so, yeah, the way we were swapping between sine and cos, you can do the same with tan and sec. Let's see. That's going to be very similar. Okay, there's a lot of stuff. Okay, so differentiating trig, what do you give yourself?
Maybe a tick.
Yeah. So this stuff, all right, it's not bad. And then afterwards, parametrics. Okay. Yeah, how was that for you, Andrey?
Tricky stuff.
Yeah. That's I think differentiating trig identities and stuff is I think it's the hardest in A level, even though it's not at the end of the like the last chapter or whatever. So I'm just gonna next time finish these questions because there's some there I could put them as homework, but they're yeah, let's leave them. And then next thing, how are you feeling now?
I'm feeling much better. I've been taking like painkillers the last couple of days, and I feel a lot better. So I'll be back to normal by next week to go to school and stuff. So yeah.
How's Yana doing? You said she tested positive.
She tested positive, but I mean we all feel fine. It's just at the time we just had symptoms and stuff. My sister's fine; she'll be fine to go back as well. So yeah.
And how did you get a coronavirus test? Was that school or something?
I never actually got tested. It was my sister. She came back from. We went out to a restaurant like before lockdown, and then like a couple of days later, she just felt sick, and then but it was minor. It wasn't anything major. So, she just took a test because she wanted to, and then it said that she was positive. So we just had to self isolate.
Where did she get the test? Do you have to go somewhere?
Yeah, she went. I think she just went to a pharmacy or to our local GP or something to get it. I'm pretty sure it's from our local pharmacy, but yeah.
Okay.
Yeah.
So I didn't know where you can get these things. All right. Anything else?
No, I don't think so.
All right. Well, yeah. Well done, Andrey. You did great, and look forward to talking again next time.
Cheers. Thank you. See you on Friday.
All right. Take care. Goodbye.
All right.